Good day, beautiful people. Swift here. You're watching Swift Tuition, and in this video, I'll be covering surds and rounding accuracy. So how to locate square roots and round real numbers appropriately. For more free maths help, use the first link below in the group description to join your Grace free WhatsApp group. I'll be sharing selected resources, updates, and occasional free sessions there. If you want weekly tuition, full worked out solutions, recordings, and the premium group, launch prices are going to be $350 to $450 until the 31st of August, depending on your grade. Prices are going to be doubling on the 1st of September. You'll find both links below. Establish an intuition of. So let's say you're given a number like this, square root of 50, and you're asked to put it between two consecutive integers. We know that numbers like to simplify nice and cute when underneath the square root sign we have got a perfect square. So the objective here is to ask ourselves which perfect squares is square root of 50 between, right? So think about it like this. We have 1 squared. That is 1, right? Square root of 50 does not feel like it's close to 1 squared, right? Let me try 3 squared. 3 squared is 9. Square root of 50 doesn't feel like it's there. Let's try 5 squared. That's 25. Not quite. Let's try 7 squared. 7 squared is 49. It feels like I'm right underneath there. So let's just keep that there. 7 squared, right? Because I know that's equal to 49. Now let me try 8 squared. Well, 8 squared is equal to 64. So somewhere along the way, I passed the square root of 50. So I know the square root of 50 must lie between these two numbers, because I know that obviously 7 squared is equal to 49 and 8 squared is equal to 64. Therefore, the square root of 49 must be 7, and the square root of 64 must be 8. Remember, square root reverses whatever the square did. Okay, so that's just our first understanding, right? So square root of 49 and square root of 64 are the two perfect squares that square root of 50 is between. So what I'll do is I'll put those right over here. So I will say, if it'll let me write it down, that'll be pretty cool. How exciting. There we go. So we've got square roots of 49 and we've got square roots of 64, and we know that square roots of 50 is therefore between these two. Now, this is obviously going to then mean that 7 is smaller than square root of 50, but 8 is bigger than square root of 50. Now, we're asked, assuming you're asked to do this without a calculator, then the way you basically do this to see whether it's closer to the 7 or to the 8 is look at the halfway points. Let's try and look at 7.5, right? You can't just rely on the fact that this, excuse me, that this is square root of 50 and 50 is close. Oh gosh. You can't just rely on the fact that the square root of 50 and square root of 50 is close to 49. Sometimes squares can work a little bit funkier than that. So we're going to use the halfway point between 7 and 8, which is going to be 7.5. And we're going to try to multiply it by 7.5. In other words, 7.5 squared. Now, when you multiply two numbers like this, we're going to use this method where you multiply the 5 with the 5. That's 25. The 5, we carry the 2. The 5 with the 7 is 35 plus 2 is 37. We're going to put a 0 there. 7 and 5 is 35. Carry the 3. 7 times 7 is 49 plus 3. 49 plus 3 is 52. And then we're going to say 5, that's 7, 1, 2, 3, 4, 5, that's 2. That carry the 1, that's 5, that's 6. And then that'll be 5. And then because there is one decimal place by the 5 and another decimal place by the 5, right? One number after the decimal point, one number after the decimal point, we're going to say 5.6. No, sorry, our decimal points will go basically 1, 2, because the fact that there are two numbers essentially in total after decimal points. If it was something like 7.05 times 7.05, then after doing the maths, you're going to have 4 decimal points. In this case, it's only going to be 2 decimal points. So the answer is 56.25. Now, that's the halfway point, of course. So ask yourself, okay, is 56.25 closer to the 7 or is it closer to the 8? Right. Well, 56.25, right, is it closer to 49? So there's 49. So okay, so getting put this way, sorry, there's 49 and there is 64, right? And this is square root of 50. Now we established that our halfway point between 7.5 is 56.25. In other words, if I were to say 7.5 squared, that is equal to 56.25. So you can see clearly the halfway point has the number 56, right? But 50 is clearly less than the halfway point, right? So if you had 7 and you had 8 over here and 7.5 over here, well, this gives you 49 and this gives you 64, but this 7.5 gives you 56.25. But we know that we're dealing with the number 50, which means the number 50 must be somewhere in this side over here. That's basically how we are going to classify our thing. So we would basically say that it is going to be closer to the 7 than the 8. So yeah, that's basically that. I will not do the long, I think it's called long multiplication for every single time, right? Obviously, long multiplication is primary school stuff, so I obviously do recommend you watching some video on YouTube or explaining how to apply long multiplication or whatever. All right, so this one asks us to place the number 82 between two consecutive integers and then say which of the two integers it is closer to. Okay, so in this particular case, obviously, I would check the numbers and stuff, and I would notice that 9 squared is equal to 81 and 10 squared is equal to 100. So 82 must lie somewhere between that, right? Because I've got the square root of 81 and I've got the square root of 82 and I've got the square root of 100, right? We know that this gives us 9, right? And we know that this is the square root of 82, and we know that this is going to be this. It's going to be 10. Okay, so obviously the square root of 82 is going to lie somewhere between 9 and 10, but who is it closer to? So you need to obviously figure out 9.5 squared. 9.5 squared is going to be 90.25, right? 90.25 is going to be, so as you can see the halfway point, right? You've got 9, you've got 9.5, and you've got 10. 10 gives you 100. 9 gives you 81, and then 9.5 is going to give you 90.25, right? And in this particular case, 90.25 is what? Well, 90.25 is going to be on which side of 82? It's going to be on the right of 82, which means that 82 must have been somewhere on this particular side. So there is the 82 over here. That's mean that the number must be closer to the 9. All right, and yeah, that's basically going to be that. Because okay, so there's square root of 82. So whatever that is, if you plug in your calculator, you would see that number is going to be obviously closer to 9. In fact, it is equal to 9.055. All right, which is clearly closer to the 9 than it is to the 10. Okay, and that's basically that. Now, Swift makes a bit of a blunder here. We're going to say, you see that Swift says that since 118 is close to 121, the square root of 118 is basically 11. I say a blunder, but I did do engineering, and a very common thing in engineering is to make egregious estimations, right? So, and engineering students will always like to round things up a lot. So that is very, what's the word? Symbolic. Okay, so we want to first of all find the neighboring perfect squares, right? What are the perfect squares close to that? Well, turns out I've already given you one of those, which is going to be 11, right? So 11 squared is going to be equal to 121, and 10 squared is equal to 100, right? 10 is just below 118, and 10 squared is just below 118, and 11 squared is just above 118. So those are perfect numbers, right? But you go through every single number, 1, 2, 3, so on and so forth, until you get to a good fit, right? In this case, 10 squared gives us 100, 11 squared gives us 121, which must mean that square root of 118 must lie somewhere in between the two of those. So we get the fact that 118 must be smaller than 121, but 118 has got to be bigger than 100. And from that, we get the relationship that 10 is 100 square root of 118 rather is greater than 10, but less than 11. So we know that that is going to be the case, right? Now, who is it closer to? However, we'd obviously look at 10.5 as we've been doing, right, to see which one that's going to basically be. But I'm not going to go through the entire process and stuff of multiplying the 10.5 thing. But I'll just give you the final answer over here, right? This one is going to be 10.86 so on and so forth over here. So let me just say 10.9, 10.9. So clearly it's going to be closer to the 11, right? So it is fine to say that square root of 118 is close to 11, but obviously it makes more, you have to be a bit more, it's better to show that it's an approximation as opposed to equal, right? This is incorrect. So you'd rather have to say that we're talking about the square root of 118 is approximately equal to 11, because obviously this is 10.9 if you round it off, and rounding it off 10.9 to the nearest whole number is going to obviously be 11, all right? Or nearest natural number, it doesn't really matter. Okay. So place 118 between two consecutive integers. I already said so. I already done so rather. And then rounded off to one decimal place, right? Your calculator will give you a couple of different things, but obviously this is going to be 10.9 if I were to round it off to the next decimal place. Obviously, when you talk about rounding off to the next decimal place, we need to worry about, so in this case it's 10.86278, right? And they ask you to round it off to one decimal place. So you're going to, first of all, okay, this is the decimal. One decimal place means that the answer will be somewhere in this space. If we'll put the answer in this space, so it'll be 10 point something. Now, does this 8 go up or does the 8 stay the same? If the number over here, the next number is 5 or larger, then the 8 will go up. If the number was like 8.4, for example, then it'll just be in 10.8. But here, clearly, you can see it's 10.86. So obviously, we'd have to bring this up, and that becomes 10.9. So that's going to be your answer over there, and we've got that right. Okay, cool. And then, okay, yeah, and I already explained the other reason why that's incorrect. It's just inaccurate. You'd rather have to use the approximation as opposed to state that it's going to be exactly equal. Now, this next question asks you to round off to 2 decimal places and 3 significant figures. Now, significant figures is a whole thing, which really should be a video on its own, and I just wasn't too sure if y'all are going to be covering significant figures or not. It wasn't when I was there, but I was just going through a couple of questions from a few different schools and such, and I had seen a question here and there, so I figured might as well just include a few significant figures examples, but it's not really something that I've seen tested, so I wouldn't stress out yourself too much about that. But let's round this off to 2 decimal places. This is 27.846, right? So it says 2 decimal places. In other words, you're going to be able to say 27, or usually 27 point something something, all right? Just 2 things over here. So that means that we need the number in this second position to change, right? So this number over here will either go up or down. Now, what did I say in the previous question? If the number after the number we want is going to be 5 or larger, then this number goes up. If it's less than 5, it stays the same. This is clearly larger than 5. It's a 6. So we're going to say over here 8, and the 4 goes up and gets promoted to a 5. So this is 27.85. Now, significant figures is a whole other can of worms, right? But in this specific context, significant figures, you want to think about significant figures as what's important for estimating a problem. So for example, if I told you that, what you may call it, that someone, I don't know, that someone weighs 50 kgs, right? Chances are they don't weigh exactly 50 kgs, right? I've kind of like approximated things a little bit for your sake over here, right? The most important number, or the significant number over here, is going to be the 5 over here, right? I'm getting somewhere. Now, let's say someone said that, okay, this person weighs 50.3. All of a sudden now, it's, if I had to specify 50.3, then I'm probably being very accurate. So now this is going to have 3 significant figures. So a couple of rules for significant figures is that if you're going to have a number, then if you're going to have it before the decimal point, and there's no decimal points whatsoever, right, where your first 0 starts, that'll be the end of the significant figures. So if I had 1, 2, 7, 1, 2, 3, 4, 5, 6, oh, this house costs 127 million. The house probably doesn't cost 127 million. Maybe it's 127,346,524, right? But I've decided to just say 127 million. So the important numbers that you worry about are going to be these first 3 numbers, right? Those are going to be the significant figures. But if I said 0.3 or 0.4 or whatever, all of a sudden, now it's important, because why do I have to specify that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this question, this example has 10 significant figures. Now, let's say, for example, I'm looking at a different instance where I'm going to say 0.003. Now, if it's after the decimal point, the zeros that come before don't matter, right? So after the decimal point, the zero that comes before the first non-zero number don't matter. So in other words, in this case over here, only the 3 is a significant figure. This only has one significant figure. That being said, if I gave you 3.003, all of a sudden I had to specify that there was a 3 over here. So now we have 1, 2, 3, 4 significant figures. So that is going to basically be that. That being said, if the zeros are after the 3, then those are going to be significant. 0.00300. Now, as you can see over here, these are obviously going to be quite important. So these are going to be 3 significant figures. An easy way to figure out the significant figures is to just try to write it in scientific notation with 1 decimal point. So for example, if I had 132,000, let's say 132 456.700 or whatever. In scientific notation, I would say 1.32. No, I wouldn't. Okay, no, sorry, not 1 decimal point, right? One number before the decimal point. So that'll be 1.3245667. I don't need to specify the 00 over here. I can just say times 10 to power of, and obviously we went back 1, 2, 3, 4, 5, right? Times 10 to power of 1, 2, 3, 4, 5 times 10 to power, no. Yeah, times 10 to the power 5, right? That makes 1, 2, 3, 4, 5. Yeah, so this over here is going to be that. So the number of significant figures are 1, 2, 3, 4, 5, 6, 7. All right, so 7 over there. So that this question specifically has 7 significant figures. To take it to this over here, as you can see over here, we want to have 3 significant figures. So that'll be 2, 7. That's already 2 significant figures, point, and then we're going to have the 8. And that's going to give us 3 significant figures in total. So that is that. That's just if they ask you about significant figures, though, as I mentioned, it is not necessarily going to be all that important. Okay. But if you are in the group chats, just when I ask for polls for things that you want me to make some like slides or some cheat sheets for, just ask and then we will send out a significant figures cheat sheet if necessary. All right, cool. Then this one asks us to round off the nearest integer. So integer starts over here. So we're going to look over here. Again, it's a 6, which is bigger than a 5. So we know that it's gonna go up. So we want to say 409. No decimal points because we just want an integer. Now this says 1 decimal place. So obviously 1 decimal place is here by the 6. So we look at the next guy over here, and this is a 3, which is less than 5. So the 6 stays a 6. So it's just going to be 408.6. Now 3 significant figures, as you can see over here, when I start with the 4, that's 1 significant figure, the 0 is a 2nd significant figure, and the 8 is a 3rd significant figure. Zeros in between don't change, right? So that's 1, 2, 3. So these are 3 significant figures already, right? So now I need to round it up or round it down. So I look at the 6 over here, and I can see that obviously I need to round it up. So this becomes 409. So in this case, nearest integer and 3 significant figures happens to be the same thing, right? But it's not always going to be the case. Okay, so that's about that. Now, the next question tells us that a slide template for a Swift lesson has a picture box with the width of 1.847 meters on the design scale. We want to round the width to the nearest centimeter, writing your answer in meters. And so in this case over here, that's obviously 1.847. So how do I take 1.847 and round off to nearest centimeter? First of all, I need to convert it into a centimeter. So what is a centimeter? Well, if you know that there's 100 centimeters in 1 meter, we can use this as our framework, right? So 100 centimeters in 1 meter, that's important, right? 100 centimeters in 1 meter. That means that whatever the meter is, you can see we multiplied it by 100 to get to that. So if this is a meter, I must first of all multiply it by 10, all right? But that's not going to be done. I'm going to first of all multiply by 10, and I get 184 0.7, right? That's just part of the question, right? That's just me getting it, first of all, into centimeters, but it says nearest centimeter. In other words, not, sorry, that's centimeter. It's not something point something. It's a nearest centimeter. So what does that mean, therefore? I must look, okay, this is the nearest centimeter. I must look at the next number over here. So I'm focusing on the 4, but I look at the number after the 4, and I realize that I can go up. That'll be 185. So in this case over here, the answer to number 1 is going to be 185, because after the decimal point, it is a 7, which is bigger, obviously, than a 5. So we need to go upwards. So that's going to be the answer to the first question. Second question asks us to round the width to the nearest 0.1 meter. In other words, to the nearest tenth of a meter. Right, sorry, I'm not done. Sorry, it asks us to then write your answer in meters. So I've written in centimeters right now, but if I had to multiply by 100 to get into centimeters, if I had to multiply by 100 to get into centimeters, I need to divide by 100 to get it into meters again. So it's going to be 1.85, and that takes me back to meters. All right, now round the width to the nearest 0.1 meter. Right, that is literally the same as saying to nearest 1 decimal point. So just round it off to 1 decimal point. So if I'm trying to round this off to 1 decimal point, what is that going to be? Right, well, that's going to be 1.8. I focus on the 8 and I look at the number after the 8. So I focus on the 8, but I look at the number after the 8 to tell me what I'm going to do with that particular 8. Does the 8 go up or does the 8 go down? Well, this is obviously going to be a case whereby the or stay the same. Sorry, obviously the 4 forces the 8 to stay the same. So this is simply going to be 1.8 meters, and that's about that. Okay, and then the final question is going to say, which rounded answer is better if the designer must cut a printed board? This is just about, obviously, your interpretation of this particular thing. And if the designer is supposed to cut a printed board, the nearest centimeter is better because it loses less information, right? You want to be as specific as possible. Swift obviously needs a board of a certain size over here, and you don't want to obviously give him less than he needs, right? Imagine he needs 1.847, but you only give him 1.8, right? Where's my 1.847? Yeah, where's my 0.047, right? I don't have the whole part I need. So it's better to obviously give me what I need, what I need, or even a little bit above that, right? So in this case over here, you would obviously say, okay, let me just write that down so that we have a bit of an understanding. I would say, in this case, for cutting a printed board, the nearest centimeter, oh gosh, the nearest centimeter is better because it loses less information, right? And just for comparison's sake, I would say also that 1.85 meters is much closer to 1.847 than 1.8 meters is, right? That's also meters. Yeah, that's basically how I would answer that. Cool. Hope you found this video helpful. You can obviously download this PDF by joining the free WhatsApp group chat.